All right, guys, so we'll finish up the review sheet, and then you'll have time to start on the test and then finish it tomorrow. That way, it's not or you're not feeling the pressure to try to get it all done tomorrow or worrying about it on Friday. So we're going to look at 3 more problems. One, finding the square root, and then kind of nth roots with these here. Now, luckily for these here, the last ones that we're doing, it's a lot of just calculator work, setup and calculator, setup and calculator. So we can look at either one of these here. So we can do 44, 2 plus 2i. So we need to get this into polar form. So we need to find the r value, which is going to be the square root of a squared plus b squared, our 2 values squared. Now at this point here, we can grab a calculator and go second square root 2 squared plus 2 squared, and it's going to tell us that it's 2 square root of 2. Now theta is going to be tangent inverse of 2 over 2. And again, for these here, when we plug it in, tangent inverse of 2 over 2 is 45. So you can put it in degrees or radians. I'm not going to knock you off for one or the other. You can pick which one you want. So this here is 45 degrees. And most likely, well, not most likely, if it gives you a positive angle for tangent inverse, it's either going to be in the first or third quadrant because of the signs. Now, since we're positive and positive, well, that means we are in the first quadrant, so 45 degrees is our angle. We don't have to do anything to it. The only way that or reason we would need to do anything to the angle is if we're in another quadrant other than 1. So if we're in 2, 3, or 4, then we'll need to do something to the angle to get the correct measure. So at this point here, now we do have our n value. It is 2 because we're taking the square root. And our k values are going to be 0 and 1 because our k values are 0, 1, 2, going all the way to n minus 1. So since n is 2, the biggest value we can have is 1. Now that we have all this here, we can go on and get started with the setup. Now for us here, we're going to be taking the square root of 2, which is not very convenient. Cosine of theta is 45 plus 360 times 0 all over 2 plus sine of 45 plus 360 times 0 over 2. We have this here. Now square roots of the square root, so square root of 2 square root of 2 is not something that's going to be easily simplified. So I'm going to look back at this here. Now if we'd have worked it out, this would have been 4 plus 4, which is the square root of 8, which is really telling us that this is the same as the square root of the square root of 8, or the 4th root of 8. So on some of these here, it's going to be easier to leave it as the square root of the number and not simplify it. And sometimes if it does simplify all the way down, it works easier that way. I will look back at the problems and see and let you know if it's going to be easier to just leave it as the square root or is it better to simplify. So I'll let you all know ahead of time. Now, the rest of this here is actually not that bad because at this point here, we can plug in 45 plus 360 times 0 over 2. 45 plus 360 times 0 all over 2. 45 halves. So we come in here and say 45 over 2 plus I sine of 45 over 2. And at this point on the test, that's as far as I'm going to ask you to take it. I'm not going to ask you to convert it into decimal form or into actually multiplying it out, finding out what cosine of 45 over 2 is and sine of 45 over 2, and then multiplying it by the approximate version of the fourth root of 8. Now, if you wanted to put 22.5 for both of those angles, that's fine. It's the same measure. And 22.5 is a nicer value than whatever cosine of 22.5 would actually be. So that's C0. That's our first one. Now our next one, well, we'll still have the fourth root of 8. We'll still have that value. Inside both of these parentheses here, we're really doing what? We're changing the 0 from the first one to a 1. Now we could go back in and put in, at this point here, that it's 45 plus 360 times 1 all over 2. Or I can come back to the calculator, reselect this here. I'm going to have to, and change it from a 0 to a 1. Or I can just put 405 over 2. In its stead. Because now that we have it already set up, we had it set up from the first one, I might as well just go on and calculate the new angle and go from there. Does that make sense? Because we could have rewritten it back out with the fourth root of 8 times cosine of 45 plus 360 times 1 over 2 plus I sine of 45 times 360 over 2. Simplify those angles and rewritten it out there. Or we can just do this here. That's it. Questions on this here. Now with the 405 over 2, you could have rewritten that as 202.5. You can written it as the decimal version of it. I would take either. Questions on these here? Oh, wrong way. Well, both of these are, so fifth root, sixth root, 46, 47, or 48. Which one of those do y'all want to look at? The fifth root of 243 cosine of pi over 6 plus I sine of pi over 6. Now this one is kind of nice because it tells us that R is 243. And it tells us that theta is pi over 6. N is 5, which means K is 0, 1, 2, 3, 4. We're going to have 5 roots that we're going to take. Now Z0 is going to be the fifth root of 243 cosine of pi over 6 plus 2 pi times 0 all over 5. Now with this here, since we're dealing with pi, our radians, we're going to use 2 pi instead of 360. Now we can look at this here, so 5 second nth root, 243. That's unfortunate. Make sure, 243. We're taking the fifth root. Okay, so 43. Did I put 34? Yes. $43. Yes, thank you. That is nice to know, because from here on out we can say that that is 3. I didn't think past me was mean enough to put a decimal number on a fifth root. Now, inside the parentheses, pi over 6 plus 2 pi times 0 over 5. Fraction pi over 6 plus 2 pi times 0 over 5 is pi over 30. And we have this here. Now, normally at this point, especially on the homework, we would see what cosine of pi over 30, sine of pi over 30 is as a decimal, multiply it by 3, and we'd get our answer. But for the test, I'm not going to make y'all do that for each and every single one. This here is the answer for Z0, for our first root. Now, what's going to change to the next root? Well, this 0 is just going to become 1, yes? That's the only real difference. So, for Z1, I know I'm still going to have 3. Cosine. I'd grab a hold of the calculator, come back up here, and change the 0 to a 1. So we get 13 pi over 30, which means this here is 13 pi over 30 plus I sine of 13 pi over 30. Now Z2, well, all that means is that this 1 is now a 2. 5 pi over 6. Well, for Z3, again, we come back to the calculator. Three. 37 pi over 30. Almost forgot that one. And lastly, Z4. $49 pi over 30. There are the 5 answers. So really with this here, it's not so much doing a whole bunch, well, it's a whole bunch of just calculations. And once we get the first one set up, it's just doing iterations of it to get the rest. Questions on this here? Even with pi, it's not that bad, especially since we don't have to type the whole thing in. Now we do have these last two here. We can look at number 50 just to finish it off, fifth root of x to the fifth minus 243. Well, the first thing we'll need to do here is actually add 243 to both sides. For any of these problems here where it's asking us to solve this equation, we need to get whatever x is, it doesn't matter the power, we need to get it by itself, everything on the other side. So if we have I terms, they need to go over. If we have numbers with it also, they need to go over. And then we need to get this into polar form. So r is going to be 243 squared plus 0 squared, because b is 0. The number in front of I is 0. Well, that's 0 squared is still 0, so we're really looking at the square root of 243 squared, which is just 243. Theta is going to be tangent inverse of 0 over 243. Now we can type this into the calculator, and it's going to tell us that it's 0 degrees. Because if you think about it on the coordinate plane, we're on the positive x-axis. And we always start from the positive x-axis, so we're actually at 0. Second, tangent inverse 0 over 243 is 0 degrees, or 0 radians. They're both the same. So we have this here. N is 5, which means K is 0, 1, 2, 3, 4, just like the last one. Z sub 0. So we have the nth root of r. Well, that'd be the 5th root of 243. Cosine of 0 plus 360 times 0 over n, so n is 5, plus I sine of 0 plus 360 times 0 over 5. Very good. Other way. There we go. Now, luckily for us, we already know what the 5th root of 243 is. It's 3. Parentheses. Now we can figure this out. So 0 plus 360 times 0 over 5. Well, 0 is really not adding anything to it. We can still add it. 0 plus 360 times 0 divided by 5 is 0. Cosine of 0 plus I sine of 0. Now, for the rest of these here, we can follow exactly what we did on the last one. Questions on this so far? So, I can come back over to the calculator and just change the 360 to a 1. So 0 plus 360 times 1 over 5, which is really just 360 divided by 5, which gives us 72. 72 plus I sine of 72. Then we can do it again. So really this time we're looking at 720 divided by 5. Now we can do this again. I have a feeling we're going to get 180. 216. Nope, I was wrong. 216. Because we're just really adding 72 each time. Yeah, that's right, because it's 5th root, not. And then we can do this one more time. 4, which would give us 278 or 288. Yeah, 288. and that there is our final answer. Because if we did it again, Z5 is just going to give us an angle of 360, which is going to give us the same as 0. So we have our 5 answers. Questions on this here? I'm pretty comfortable with all this? Yes? So, yes, if you need to get your calculators, you can go on and grab them. I'm going to go on and let y'all get started with this here. That way you have more time to get it done.